In this video, we'll be defining domain and range, and we'll also be looking at different formats in which we can give the domain or the range, depending on what the graph looks like. So let's start off by talking about what domain is. So the domain of a graph is all possible x values. Alright, so it's not hard to know what's going to come next. The range is all possible y values. Alright, so this is useful because, I might want to see a graph, for example, or somebody might want to show a graph, and you don't want to show every single thing. You want to specify, well, I want to see the graph in this domain. So from left to right in this domain, this is what I want to see. It's just like saying, well, I want to go to New York City. Where are you going to go? Well, I'm going to go in the Upper East Side and look in that area. Or, you're basically just saying this is where you're going to focus on the graph. All right, that said, let's talk about how to actually state the domain of a graph. Okay, so first we're going to focus on domain. We're going to look at different examples that work in different ways to make sure you get it, and then we'll move on to range. So for domain, you want to make sure that you ask yourself, where is this graph starting and where is it ending? But specifically from left to right. So for example, I'm going to throw a graph up here, and my graph is going to do something interesting. All right, so let's say this is 90, let's say this is 180, and let's say this is 270, and let's say there's an arrow going that way. That's my x-axis, that's my y-axis. The first thing that's probably most important is what exactly, let's give this endpoints, by the way. What exactly am I referring to when I say my graph? When I say graph, am I referring to my entire picture here? I am not. In fact, I am only referring to the shape that is within the coordinate plane. So the x and y axis are my coordinate plane. The shape within my coordinate plane, that is my graph. So I want to know where my graph starts and ends from left to right, because it will tell me where my first x value is and where my last x value is. Where's the starting x value and where's the ending x value? So in this particular case, the graph starts at 0 and it actually hits that point 0. So if I wanted to put my graph in a little, border line, for example, I would have a line over here at 0 and it ends here on the right side at 180. So from left to right, it's going from 0. And we can say this in words, but this is not how you would write it in an actual mathematical way. But it's going from 0 on the left to 180 on the right, which means that in mathematical notation, the way we would write this down or answer for the domain here would be 0 is less than or equal to x, which is less than or equal to 180. And that's the domain. And sometimes people say D and a colon and then they give the domain. So that's our domain. All right, so that example was somewhat straightforward. It can get a little bit fishier. So I'll show you a couple more examples. Okay, so another question to ask yourself would be, is there a vertical asymptote? So if there is, well, first of all, do you know what a vertical asymptote is? A vertical asymptote is a line, so in this case, it's at x equals 2, a line that the graph approaches, gets infinitely close to, but does not touch. So it's approaching it, it's getting closer and closer and closer and closer, but it will never touch it. So this graph actually goes all the way right off the screen, and it also goes all the way left off the screen. But from both directions, it's going to approach this line, but it will never ever touch it, which means that x can be anything except 2 in this particular case. For that reason, instead of me trying to list infinitely many numbers and leave off 2, not possible, I can just say that x is not equal to 2. And that is my domain. Let's look at another case in which there's a vertical asymptote. All right, so here's my graph. And let's say there's an asymptote at 4. Why not 4? All right, and let's say the graph, for some reason, is approaching that asymptote, approaching it, and will not touch it, but it is going all the way left. All right, in this case, well, it's going to approach our asymptote. It's going to get infinitely close to it, but it will never touch it. It will be everything less than 4 in this case, so our domain in this case is x is less than 4. Could it be less than or equal to 4? No, it could not be less than or equal to 4. What's the reason for that? Well, because it will never touch the asymptote, it can never actually be equal to 4. All right, so that's one other thing that we look for. We look for asymptotes, and then we look for whether or not it will never be equal to that number, but it could be everything else, or perhaps it could be everything less than that number, or maybe everything greater than that number. So we look for that asymptote and see what hints it can tell us. Let's look at another example. All right, so every example so far has looked so different, but not to worry. Once we go over the basic examples, it's usually going to be one of these 4 things. So this is the third of 4 things that it could probably be. All right, so if you have a series of points like this, let's actually put the coordinates on these points. This is 2, 1. We have here 3, 1, 2, 3, 4. I know this isn't the greatest drawing, but just forgive that. And we have here 4, 1. All right. So if we have a series of points, we're not going to use the inequality signs here. Do not fall into that temptation, because it can't be 2.5, for example. It can't be 3.5. It can really, x can only be these 3 things, which means our domain is actually x is equal to 2, 3, and 4, and nothing else. So you just list out those values. So if you see points, just list the values. Do not give an inequality. All right, one more example of domain, and then I'll quickly go through range, because the idea is very similar. Okay, so hopefully you recall that the domain is all possible x values. So you're looking from left to right. Where can x be at the start? Like, where does x start on the left, and where does it end on the right? Well, in this case, it doesn't have a starting point. This arrow is going that way, which implies it keeps going. It could go on and on forever and ever and ever and ever, and never, ever, ever stop on the left. Similar for the right. The right, sorry, it goes on and on and on and on and on and on and on, never stops, keeps going to the right. All right, which means that, well, there is no breaking point. X can actually be anything at all. X can be all real numbers. And the way that we write that x can be all real numbers, that x can be anything, is like this. X is a member of the set of all real numbers. This is just the way that you write x can be any single real number. From left to right, x can be anything. All right. So now that we've explored domain, I would like us to quickly go through range, and just, it's very similar. I just want to make sure that we have it down as well. Okay, so remember that for domain, we were asking ourselves, where does this graph start and end from left to right? Well, in range, what we're asking ourselves is, where does this graph start and end from bottom to top? So we can actually put this, in a box, kind of like borderline the bottom off and borderline the top. And we can see that this line is at -1, and the top line is at 3. So from bottom to top, our range goes from, and I'll write it in words first, from -1 to 3. But of course, we want to have it in nice, wonderful set notation with our inequalities. So it is range, and we can put a R and colon. Range is -1 is less than or equal to x, which is less than or equal to 3. And so that's how we do the range. Now, the same variations will happen for range as it did for domain. So let's quickly go through them. Okay, so similar question, but instead of asking if there is a vertical asymptote, you're now asking if there's a horizontal asymptote, and there is one. It is at y equals -2, which means that this graph is approaching -2 but will not touch it from the top. Same from the bottom, approaching it but will not touch it. Y can be anything in this graph, the black graph. Y can be anything except for 2, which is why the range is y is, that looks like a weird looking y. Let's try that again. Y is not equal to 2. That's our range. Okay, so we have a funky looking graph here. It's a series of points. All we have to do is list the y coordinates of these points. So if it helps you to see what all the coordinates are, you can write them down. -2, -2 here, and we have -1, -1, -1, -1. We have 0, 1. We have 1, 1, and we have 2 and 2. All right, so as you will probably notice here, we have 2 as a coordinate here, a y coordinate. We also have 1 as a y coordinate. And that's actually the only y coordinate we have. Everything else is repeats. So our range is just 1, 2. That's it. We don't have to write the repeats. Okay, so finally, this is our last example. In this case, y is going all the way up, all the way down. Remember that the range is really where y goes from and to, from bottom to top, but there is no bottom. It's infinitely going down and infinitely going up, so y can actually be anything, which we should know how to write that now, and that is written: y is a member of the set of all real numbers. This just means that y can be anything. All right, and that's domain and range.